You are one of 55 participants in a rock, paper, scissors tournament. A match between two people is played one at a time, with the loser dropping out of the tournament. The only condition is that in each match, the number of wins so far between the two participants can differ by no more than 1. Now, the question is, if you manage to somehow win the entire tournament, then what is the maximum number of wins you can get under your belt? Okay, first things first, let W sub I denote the number of wins so far gathered by each participant, and let A sub N represent the maximum number of wins one can get in a tournament with N participants. It's clear to see that for a tournament with only 2 people, this value must be equal to 1. As for a tournament with 3 people, the winner would have to beat one person and then beat the other, which brings the maximum value up to 2. For a tournament with 4 people, this value also comes out to 2. For a tournament with 5 participants, we need to be careful because if the winners of the first round play each other, then the winner of that wouldn't be able to play against the participant that hasn't played yet, since the difference between their wins would be more than 1. So the tournament would have to go down in this fashion, with the maximum number of wins this time coming out to 3. Now, if we take a look at our values again, it seems as though we just need to keep adding 1 to A for every odd value of N. But after going through a few more iterations, we'll find that this is not the case. So what's the pattern then? Well, let's highlight all the values of A that provide a jump in the maximum number of victories. We want to define a sequence that directly targets these values to make things simpler moving forward. One way of doing this is to let B sub k represent the minimum number of participants required to be able to produce a winner with k victories. And just like that, we have a cleaner list of equations, where the value we're trying to determine is x, such that B sub x is equal to 55. Now, something you might have already noticed is how these values have somewhat of a Fibonacci quality to them. And you know what? That's no coincidence. See, in order to have a tournament winner with k victories, we need a participant who has k-1 victories so far and have them beat another participant with at least k-2 victories so far. And since this is a single elimination tournament, meaning you're out after only one loss, then it's not possible for anyone to lose to both of these participants. Therefore, we need enough participants to produce a player with k-1 wins, or b sub k-1, and we need enough different participants to produce a player with at least k-2 wins, or b sub k-2. And there we have it, a recursive formula for b sub k, which just so happens to be a shifted Fibonacci sequence. Thus, the maximum number of wins you can acquire in a tournament with 55 participants under the given condition is just 8. Okay, here's a question for you. What if instead the tournament had 100 participants? What would be the maximum number of wins one can get this time?